Hi everyone, this is your 12-3 lesson on trig functions of general angles. So we're going to take what we learned last time and apply it to more general angles, not just special angles around the coordinate system. So the first thing I wanted to review is the quadrantal angles. So we've talked about these before. These quadrantal angles are the angles that divide the quadrants. So here's my first quadrant, my second quadrant, my third quadrant, and my fourth quadrant. And so the axes that divide them, if you were to rotate onto those axes, that's where these quadrantal angles occur. And they're pretty intuitive. 0 degrees always starts on the positive x, 90 ends up on the positive y, 180 goes all the way around to the negative x-axis, and 270 goes down to the negative y. Okay. What we're going to be looking at differently today is instead of using h for our hypotenuse, we're going to switch to talking about the hypotenuse as if it were a radius. Okay, because honestly it is. At this point, when we have a point in the coordinate system, we have three ways to measure that location. We can use our traditional x and y coordinates, so the x coordinate describing the horizontal distance, and the y coordinate describing the vertical distance. But we can also now use the amount of rotation and the distance away from the origin to describe this location. So the hypotenuse of the triangle also describes how far this coordinate is from the origin. Okay, so that r radius, we can use a couple of things to solve for. We know that the two sides squared added up should equal the hypotenuse squared. So we'll be needing to use that to solve for the radius. And then we also have this angle of rotation theta that always starts from the initial side, right here on the positive x-axis. Okay, so in this lesson we're going to be talking about angles that are not necessarily between 0 and 90. And so it's important that we talk about this reference angle vocabulary word. The reference angle describes the angle created by the hypotenuse that goes the shortest distance back to the x-axis. So in this picture right here, this angle inside the triangle is my reference angle for the larger one outside. So we call this theta prime. That's the reference angle for theta. Okay, and those two angles have a relationship. They have the same ratios. The only difference is that the reference angle will always have positive ratios, whereas this angle should have positive or negative ratios, depending on which quadrant we're in. And you'll see in the first example how that works. So all you need to know is that if you have a theta and it's not in the first quadrant, you need to make a right triangle with the x-axis. Okay, never make one with the y. So notice I didn't draw my triangle up here. That's not how it works. You have to draw the triangle to the x-axis to get the proper reference angle. Okay? So let's look at our first example. The terminal side of theta in standard position contains the point -3, -4. So they're saying that this theta, its terminal side is here, and it has this point at -3, -4. Find the exact values of the 6 trig functions for theta. Okay, so all we're doing is we're setting up 6 ratios based on the 3 sides of the triangle. Now your question might be, well, where do I draw the triangle, right? I don't see the triangle. All I see is an angle and a ray right here. Well, they've already drawn it in for you. This may or may not be drawn in on a future example, so make sure you're understanding where it comes from. If this is my point, I want to figure out the reference angle that goes back to the x-axis. So right here, this is my theta prime, okay, right here in this triangle. And so to see the right triangle, I need to take this point and draw a vertical line, again, always to the x-axis, never to the y. So this dotted line helps me see, oh look, there's the right triangle. There's my reference angle as one of the angles in the triangle. And we will use the reference angle to find the 6 trig functions because it shares the same ratios as the larger angle out here. Okay, so the small reference blue angle has the same ratios as the red one as long as we look at the positive or negative sides of the triangle. Okay, so most of the time when we look at triangles, we only use positive sides, but because we're in a quadrant that's different than the first quadrant, we have to take into consideration the positive and negative sides of the coordinate. So this side of the triangle is actually going to be a -3, okay? This side of the triangle is going to be a -4. And so the only side we're missing to set up our 6 trig ratios is the hypotenuse, which we should be able to solve for, again, using Pythagorean. This is a Pythagorean triple, but in case you get an example where it's not a triple, this is how you would solve for the radius. -3 squared plus -4 squared equals the radius squared. Okay. So we get 9 plus 16 equals the radius squared. And so we're going to end up with 5. Okay, your radius will always be positive. You cannot get a negative radius because you're always squaring these. We only take the positive solution for the radius. It's just the distance from the origin. So while the x and y coordinates could be positive or negative depending on the quadrant, the radius will always be positive. Okay, so I'm going to plug in r here as 5. And now that I have the 3 sides of the triangle, for my reference angle, I can set up the trig functions for my big angle. So the regular theta trig functions are ready to be set up. So we'll start with the basic ones, sine, cosine, and tangent. We'll say that the sine of theta, okay, that should be the opposite side. So looking at your reference angle, the opposite side is -4 over the hypotenuse, which is 5. For cosine of theta, I'm using the adjacent side, which is the -3 side, over the hypotenuse, which is 5. And then for tangent, we're looking at the opposite side, which is -4 over the adjacent side, -3. So -4 over -3 simplifies to 4/3. Okay, so -4 fifths, -3 fifths, and 4/3 are our 3 trig ratios. The other 3 are the reciprocal ones. So this is good practice remembering which trig functions go with their reciprocal. Sine always goes with cosecant. So cosecant of theta is going to be the reciprocal. Do not get rid of the negative. Reciprocal just means to flip the fraction. So for reciprocal, this is going to be -5/4. For secant of theta, that's going to be -5/3. And then for cotangent, it's going to be 3/4. So you'll notice over time that depending on which quadrant you're in, you end up with the same type of signage for each trig ratio. So sine will always be negative in the 3rd quadrant, and cosine will always be negative in the 3rd quadrant. Tangent and cotangent will always be positive in the 3rd quadrant. And we'll talk a little bit more about those patterns in a bit. Okay, so that's how, given any point, like -3, -4, any coordinate, if you want to know the trig ratios for the angle that got you there, you should be able to figure all of them out by drawing your reference triangle, filling in the reference angle and the sides, and then just setting them up. Okay. For this next example, we're going to start working backwards a little bit to try and figure out what the reference angle is. Okay. So both the reference angle and the original angle. So here we have an angle starting with the initial side, rotating negatively. So I can already tell this is going to be a negative angle of rotation. This is going to be my theta. To help me find theta, I'm going to solve for theta prime, which is back here. Okay. So for theta prime, I can see that I need at least one point. I can use that point to draw the reference triangle back to the x-axis. So make sure you don't draw it this way to the y, always to the x-axis. And so I'm just going to draw this a little bit bigger. So we can see. There we go. Okay, so this is my reference angle that I just pulled off from there. And so this side is -2, and this side is -2. And here is my angle that I'm looking for. Okay, so hopefully you could tell that because two sides of the right triangle are the same, that this is a 45-45. So automatically know what this angle is. Okay, if you didn't know what that angle was, you would have to use your calculator and set up a trig ratio and then do an inversion. So you would say that the tangent for theta should be opposite over adjacent, which is 1. And then to solve for theta, we would do the inverse tangent of 1. If you put that in your calculator, you'll get either pi over 4 in radians or 45 degrees. So that's the measure of my reference angle, but that's only one of the questions. All right, so we're going to say that theta prime for our reference angle is equal to 45 degrees. And that's this tiny angle in here, but I now need to figure out what is the angle starting from the, that's drawn in here, starting from the initial side and rotating clockwise. Okay, so it's going to be negative. I know that the full rotation to this side is negative 180. So if I want to go backwards 45, all I have to do is add 45 to that to go in the reverse direction, and I get that it's negative 135. Okay, so our actual angle of rotation is negative 135, while the reference angle was 45 degrees. Okay. All right, let's look at one where we don't have, well, we actually do have a special ratio in this one as well, but it's not as simple as the 45. So you may recognize these ratios from our other special angle, but let's take a look. So again, I'm going to draw my triangle. It's in the third quadrant again. And I'm going to draw it outside. And this time, I'm not 100% sure what this angle is, but I know that the two sides here, this side is x coordinate of negative 1, and this y coordinate of negative square root of 3. And then here, again, is my reference angle. Your reference angle is always the one touching the origin, so it would never be down here. Okay, this is that point, negative 1, negative 1/3, but your reference angle is up here. So now to figure out what the angle measure of the reference angle is, I either have to remember my special triangles or set up a trig ratio. So again, if you want to use tangent, you'd say that the tangent of the opposite side, negative square root of 3 over negative 1, and then you would do the inverse tangent of that. Okay, so that's just the positive square root of 3. So you could type that in your calculator and it would approximate, it would actually give you the exact angle. But if you remember your special angles, right, this is the longer leg and the shorter leg, and because it's 1 times the square root of 3, or negative 1 times the square root of 3, I know that this is my 30, and this is my 60, and that this length here would be 2. Okay, so this is actually a 60-degree angle. So if you type inverse tangent of square root of 3, you will get 60 degrees. Okay, so that's my reference angle, theta prime. Oops, I forgot my prime in there. So theta prime is equal to 60 degrees. So again, for my reference angle, this time I'm going positively. So I'm going to do 180 to get here, plus another 60 degrees. So my total angle of rotation is 180 plus 60 degrees. So always look at the direction you're going. That's 240 degrees of rotation. So theta here is 240 degrees. Okay. So again, theta prime is your reference. Theta is your overall angle. Okay, this is discussing the unit circle again in a 360-degree angle. If you set all of your hypotenuses to be 1 unit long, that generates all of your coordinates on the unit circle. And so you can see that we've actually created a pattern that we can use sine and cosine to figure out the x and y coordinate. Okay, the only one that usually confuses students is when we get to the quadrantals. So for the quadrantal ones at 90, negative 180, 270, we're going to just practice finding sine and cosine for those based off of their coordinates. So if you have a 90-degree angle, this coordinate is 0, 1. The sine coordinate is always the y coordinate. So for the sine of 90, you would attribute it to the y coordinate of 1. For the cosine of 90, you would give it to the x coordinate of 0. Okay. For negative 180, that's down here. My coordinate would be negative 1, 0. And so the sine of negative 180 would equal the y coordinate of 0. And the cosine of negative 180 would equal the x coordinate of negative 1. And then for 270, that's all the way around here. My coordinate here is at 0, negative 1. So the sine of 270 is negative 1, and the cosine of 270 is 0. Okay. Down below is a unit circle for you to practice filling out again.